Hello YouTube and welcome back. In previous two videos, we saw how to download stock market data using jugaad-data, either through command line or through Python code. Now in this video, we will see how to use that data to do some analysis. So today we are going to see how to calculate beta for an Indian stock. So let's understand what beta means in finance. So beta is a measure of how an individual stock moves with respect to market. So when we say market, we generally mean the index. So in India, it will be Sensex or Nifty, and there are multiple indices, but majorly it will be Nifty or Sensex, right? So and it is assumed that the returns of the stock follow a linear equation uh, with respect to returns of the market. So as you can see here, return of the stock is beta times return of the index plus some constant. So the similar if you would remember from your school days, we had this y equal to mx plus c linear relationship, right? And so just focus on the returns part here. We're not talking about relationship between stock price and say Nifty or Sensex. We are talking about linear relationship between the returns of the stock and return of the index. So it will the returns are like daily returns or weekly returns or monthly returns, depending on what is the outcome that you expect from the analysis. Here in this video, we will focus just on daily returns, but you can try out other things as well on your own. So for calculating the beta, for calculating beta, we will use this particular formula is a covariance of market and stock returns divided by variance of the market returns. So it's one of the ways in which you can calculate beta. It's again, it's a basic regression analysis. If you're too much deep into the mathematics, you can probably try to derive this equation as well, but I'm just going to take this as a base. Right, so once you calculate beta, how do you interpret that, and how do you use that in your decision making? Right, so uh, basically the beta is a measure of how the stock moves with respect to index, right? So first case is uh, when the beta is positive, and specifically when beta is higher than 1. You will understand why we are kind of bucketing it as higher than 1, between 0 and 1, then negative, right? So we'll discuss each of those buckets, but the beta of the stock varies from minus infinity to plus infinity, can theoretically vary between that range, but generally it lies between somewhere minus 2 to plus 3 or something like that. I mean, so this is the general range for all of the stocks. So first case, when beta is higher than 1, let's consider it to be 1.5. what that means is if Nifty moves by 1.5%, 1% up, Nifty moves by 1% up, the stock will move by 1.5% up in the same direction. Say Nifty moves up by 1%, stock will move up by 1.5%. If Nifty moves down by 1%, the stock also will move down, but at a higher speed, that is 1.5%. So first interpretation is if the stock of the beta, beta of the stock is uh, higher than 1, positive higher than 1, the stock is said to be more volatile. So the rate at which the stock moves is much higher than the rate at which Nifty or Sensex will move, but in the same direction, right? So second case is beta is less than 1. So here the what it signifies is stock moves slower than the market, but in this still in the same direction. So if say beta is 0.5, the index moves by 1% up, stock will also move up, but just by 0.5%, right? So and similarly in the opposite direction as well. But the underlying factor here is stock is less volatile with respect to market. Hope this is clear now. And then we will go to the negative betas. So when the beta is negative, what it means is the stock moves in an opposite direction of the index. So if index say increases by 1%, the negative beta stock will decrease by corresponding beta value. Let's say 0.5 or 1%, whatever, depending on the beta. So this is whole, interpretation of the beta. So you'll ask, what if the beta is 0? This is so generally beta will have some value, either positive or negative. Uh, for uh, for securities like um, liquid Bs or which are like uh, constant always, right? Something like if you search for liquid Bs, the value of that security will always be 1,000 rupees, right? So for such securities, the beta will be 0 because it doesn't actually have any relationship to the market, right? So we cover all the scenario. Now, with this information, how do we use it? So in your construction of portfolio, when you have to diversify, beta will be an important factor. Right? If your portfolio has lot of very high beta stocks, um, your portfolio will always outperform the index. But when the stock falls, your portfolio fall. When the market falls, your portfolio will also fall much faster than the index, right? So you have to balance the portfolio with high beta and like low beta stocks as well. So right. So that's the basic principle behind the um, the use of beta. Now I'm assuming that you have already seen the other two videos. first two videos. If not, I would request you to see that, because it discusses on how do we install jugaad-data, how do we we'll have to install pandas separately. So all those things are covered on the first video. Second thing is, this particular notebook is available in on this website marketsetup.in. You need to go here how to calculate Indian stock beta. So we are just following this particular uh, the guide. So I'll include this link in the description. Uh, Now with that, now we can go to the code. So first we import all the required modules and the functions, right? So important thing to note here is we will be using index underscore df and stock underscore df to download the data. So here first thing we do is download the data from Jan to June, and the stock that we have chosen is Reliance. So we've downloaded the Nifty data in data frame called IDX, and Reliance data in uh, data frame called STX. And this is what we will reference now, STX and IDX, going forward in the code. Second step now is to transform and clean up, basically. So if you would see here in IDX data frame, you are getting this historical data as column name, whereas uh, in stock data frame, you're getting dates, that the name of the date column is simply the date, right? So here you can see. So what do we do now? So for that, we will actually change the column, this name to date again, because we would need to combine these two data frames and bring them into a single data frame. So now, uh, and second thing is, we are just interested in the closing prices. Where to calculate beta, we don't need open, high, low, close, all those columns. We just need the close columns. So close column of index and close column of the stock. So uh, first we are actually changing the column that is here. Then we are renaming it to Nifty, right? So uh, in the new data frame, if you see, this is, we have created a new data frame here, um, which is taking only two columns, as we discussed, date and closing price. And on top of that, we are renaming it to Nifty. The closing price of index, we are renaming it to Nifty. Then we are merging the stock data frame with this new data frame um, on date column, right? So, and again, so stock close column, we are renaming it to stock. So in the resulting, the final data frame, we will have three columns. It's date, Nifty, and stock. Nifty will have index closing price, stock will have Reliance ka closing price. So hope this is clear till now. Now we will move to calculation of returns, basically. So shift is one function which is already there in pandas. It will move the uh, column down by one uh, uh, by 1 basically. You can actually do put any value here, and it will shift the column by those many uh, rows. So when we say 1, it shifts the column by just 1 row. So we are shifting and calling it the previous close, right? So we have two additional columns: stock previous and nifty previous. So if you see here, like stock and stock previous, it the same value will be copied down the uh, down one column down, right? So the reason we are doing it is that to calculate return, we will subtract these two columns and divide by previous value, right? So that's what we are doing here. So nifty change is nifty minus nifty previous divided by nifty previous. Similarly, stock change is calculated this way, and the resulting data frame you get like this. So here you have these two columns, the last two columns where you are getting the returns. Now finally, there are ready-made functions to calculate covariance and variance. So here, coming back to this formula, you need to calculate covariance of return of the stock and return of the index divided by variance of return of the market. So that is what we are doing here. So stock change column and nifty change column, that is what we are passing to covariance function, and variance also we are calculating in the same way. Now if you calculate, just run this once. Right, so if you print the covariance matrix, you will see there are 4 values. So these 4 values correspond to covariance of A with A comma A, that is like covariance of A with A, covariance of A with B, B with A, and B with B. So this is how NumPy returns. But we are interested in covariance of A with B, that is stock with index. So we will either take 1 comma 0 or 0 comma 1 here. Right, so and finally calculating the beta of the stock with this formula. So you see Reliance has a beta of 1.06 during that those 6 months, right? So that was on how do we use the downloaded stock market data to calculate beta. So hope you understood something new, learned something new. Let me know in the comments below what do you want me to cover next, and I'll try to make some videos on that. Thank you.